Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 83, shortest impossible sequences of rows. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. And this one I actually spent kind of long on, 20 minutes. And one of the reasons is because, to be honest, I solved two problems. I actually misread this initially. I thought it was the shortest subarray. So I solved subarray, which as an upsell for you at home, solve the version with the subarray and then see what algorithms you could come up with. But that said, the way that I did this one is with dynamic programming. It might not seem like it, and I probably could have written it in a better way, but it is dynamic programming. And the idea here is just saying that, and let's use this as an example. And this is my very short code, but pretend you can see it for a second. The idea here is that going from left to right, the structure is that, okay, can you have a the way that I would say is that, so let me start let me start by saying that the naive dynamic programming the naive dynamic programming is maybe asking yourself, for every particular index, is there, let's say there's an f of index and the length, right? Then this question is going to be for I'm going to call a sub I, say, for a sub I, is there a sequence of length L, or a full sequence of length L. And what do I mean by full sequence? I mean that that full sequence being that all the possible prefixes exist ending with a sub I, right? That's what I mean. Maybe that's a little bit better. And what I mean by that is that, let's say here we go to 2, right? Then in this function will let me know, is there a full sequence of length, let's say 1, that ends with 2? Is there a full sequence of length 2, which in that case would be 1 2, 2 2, 3 2, 4 2, right? And then for L is equal to 3, say, same idea, but I'm not going to write it all out because that's just a lot, right? Dot 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 4 4 2, right? So that's the idea of this, is what this function is saying. Well, so that's the naive one, and of course, if you don't do it naively, this is going to be n squared or something like that. So that's going to be too slow. Or, n times L, which is n squared or something like that. But then the key thing to notice is that as you move from left to right, how do the state changes, right? So this is about building upwards as a dynamic programming. And then the question is, okay, remember that, so then the question I would ask myself now, going from left to right, is okay, is there so then the question here is, given the number 4, what is the longest sequence that I can make? Well, the longest sequence that I can make is the longest sequence that I can make at L minus 1 for some L that is 4, right? Meaning that we are trying to find okay, so we're trying to get 4. What is the biggest L for 4, right? And that means that we have to try to find an index in which 1, 2, 3, and 4 already exist previously. In this case, L is going to be 1 because it just has itself and nothing else is before that, right? So yeah. And here it goes to 2, Well, the 2, we see that there's a 4, but it doesn't have, 1, 2, 3, 4 as a prefix. So, but then now we add 2 to the set of stuff that has L of 1, right? So that means that for L equals 1, the set that we've seen is 2 and 4, right? And then here, 1, right? What happens? Well, we still need to do 1, 2, and, we still have no full thing, so that's another 1. Here 2, well, the idea is that, I think this is where it gets a little tricky, is that for L equals 2, in theory, you can imagine that now we have 1, 1, 2, 2, 2, 4, 2, but it's missing a 3, 2, right? So there are really 2 scenarios here which allow us to make this optimization. One is that, okay, so here clearly we need a 3, right? So one way that you can think about it is maybe we now keep track of, 1, 2, 2, 2, 4, 2, but then we still need a 3. And what happens when we get that 3? And we get it very soon, but what happens when we get to 3, right? Well, when we get to 3, we still need another 2 we need to get another 2 later to fill this up to get 3, 2, right? So getting a 3 is not enough. We need a 3, 2. And of course, you only get a 3, 2 if you get a 2 later on anyway. So with that logic, that means that we don't need to process these numbers in between, because if we get a 2 later on anyway, that means that there are only 2 scenarios, right? If, or maybe depending on how you want to say it, if 3 exists later, then you only have 2 scenarios. That means that if 2 exists after the 3, then we don't need to keep track because the later 2 will match the 1, 2, and 4 anyway, right? In this case, you can think about it as here, this one matches the 4, 2, and 1. We need a 3. This one matches the 3, but in a greedy way, this 2 also matches the 1, 2, and 4. So this 2 we can just ignore. That's basically the idea. If 2 doesn't exist after 3, then we can complete it anyway. So then this will never be of length 2 ending with the 2. So in this way, if you kind of do the exhaustive case proving, we can just skip the 2 because the 2 doesn't have everything. And then here, it also allows us to keep track of things much easier. Because now, here we go 3. Okay, well, there's no length, whatever, so then 3, right? And then now we know that for L equals 1, we have a full lookup, if you will. So here, then we can now say the next 3, we go, okay, is there a 3 in this prefix? Yes. So, because this 3 now have a length 1 prefix of 1, 2, 3, and 4. And there's an invariant here that we don't have to look up L equals 0 anymore because, we don't have to look up 0 anymore because we can assume that if L equals 1 has it, then it has it. If it doesn't have all the elements, then the latest number is like a frontier, right? You can only push it 1 at a time. You don't have to, everything before that is smaller. And then now you go to 2, and then 2, we can see that we could add a length 2 prefix or length 1 prefix to make a length 2 thing, and then a 4, and then 1, right? And that's basically the idea. Let's say we add another number, let's say another 2, then we can say, well, now we know that we can make every possible length of 2, let's try to make a 3. And the way that we can make a 3 is by taking this number 2 and adding it to every possible. Because here we know that, what does this represent? This actually represents, 1, 1, 1, 2, 2, 1, 2, 2, ... right? So basically, or maybe another way of saying it is 1, 1, 2, 1, 3, 1, 4, 1, 1, 2, 2, 2, 3, 2, 4, 2, because these are all the prefixes or suffixes with 1 at the last element, 2 as the last element, and ... And then here, now given this 2, we can see that because this is full, we can just add 2 to all the things and have a 2. And here, this 2 represents having all the possible lengths of 2. That's basically the idea. And of course, once you realize this, you can also just remove these older things because you could notice that we never use these again. I didn't do it this way, but you can definitely do it this way. And I basically do a very naive thing of, I keep on creating new sets in the algorithm that we describe. It is essentially dynamic programming and try to fill it out. But yeah, so two things. One was that I was on tilt from probably Q3. That's some of the slower. I was just like beating myself up suboptimally. And then the second was I literally spent 10 minutes on a subsequence one. Though I really should have Robin Cobb more readily available. So maybe I'll do that after the contest as a test. But yeah, that's pretty much it. And then we find the length of the incomplete founds, or completed founds maybe. Yeah, completed found. So that's why we add a new one if this is full. And yeah, that's pretty much it. This is so the way that I wrote is a little bit awkward for sure, but the sum of all these things is going to be linear time, linear space. In that, but and that I mean O of n times plus k time for space, and time is just O of n, assuming that this lookup is O of 1. You can actually optimize this to be O. Oh wait, this is O of n space. Sorry. I guess I'm just natural to say O of n. But O of n, because each element in row will either be in this set or the new set later, right? So this is going to be O of n space. You can actually optimize this to O of k space by only keeping track of the last two elements and then keeping track of a count or something like that. But which is, yeah. That's pretty much all I have for this one. Let me know what you think. This one is a very tricky dynamic programming problem, for sure. Even if you read it correctly, I did not. This is pretty hard, but yeah, I'm just trying to think whether this makes sense for an interview questions. It's an okay or it's definitely a harder interview question, so I don't know if this makes it for a good interview question. And I think one trap that you can fall into for sure is that you look at how people implement stuff like this, and you think that you think you can, like the logic is not necessary as easy, because the code looks easy, right? So I don't know. Anyway, that's all I have for this one. Let me know what you think, and you can watch me solve a live in contest now. Silly mistake. That's gonna be an expensive penalty. Okay, focus. NK and then. Should have gotten that one. What a silly typo. Can you brute force? Brute force maybe could be right. Let's do it. Well, I did it's 2, right? I think brute force is right, but it's just like n log n or something. Yeah, hyphen brute force, that's right. Okay. That's sad. Okay, get it quick and then we'll go home. K to the power. Doesn't matter, right? Oh, I guess it does. Oh, that's no bueno. That messes up. So for I always equal to 1. really need a rolling mod library. Debugging that for a little bit. Let's see what's that. Seems right. What is this one? It's 4. And 22. 16. That's 4. Plus 24. Oh, this is wrong, isn't it? Maybe I should. But yeah, I definitely should have had a library for this. That would have made this a lot easier. So 1 digit, 1 plus 1 to 4, no. Why? Tell me why. Come on, Larry. This is. Usually pretty good at this, but apparently I'm slow today. Okay. So now I think I'm doing stuff. Oh, and also that's why, because this is the length. Wow, what a silly mistake. Two, two, 1. Nope, it's the 3. I'm still not right. 1, 2, 3, 4. Okay, that's good. Oh, did I misread this? I think I misread this. I totally maybe misread this. Oh man, wow. Okay, I totally misread this problem. Okay. Let's look at it again then. Sequence of what does taken from rows mean? Oh, I see. Why can 2, 1 cannot be taken from rows? Because it has to be in order. This is like really poorly written. Okay, I might have misread this. 1, 4, 2. 1, 1, 2, 2, 3. I have to think about this again. Totally misread this part. I think this logic is still right. It's still gonna be unlog in, but the question is what? It's gonna be DP maybe. Now to think about, I have to reset my mind. Reset my mind. Okay. It's DP, but and I have a 5-minute penalty, so this is gonna be a sad contest, but that's okay. Do we think? Oh, I don't know. My mind's stuck on the other one. Okay. Is it just DP? Okay. Something like this where that's not right, is it? Oh, I have to do the other thing. Because then now this Well, a lot of people got IM today. It's not a good day again. But, well, I thought I could do some like weird DP, but maybe that's not quite right. Because this 2 is most, no, this, because this 2 has some length 3 stuff. Maybe I just got it weird. There's nothing. This 3 is good, this 2 is good, this 4 is good, this 1 is good. Oh, wait. Can this possibly be right? Oh, so I did have it right, but I misread it. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, these forums. I'll see you later. Stay good, stay healthy, good mental health, and goodbye.